So we'll see some more examples of ionic compounds. So you must be very much comfortable drawing the dot and cross diagrams and also finding out that how the formula unit is formed. Another very strong ionic compound, aluminum oxide, again used in ceramics and in fire resistant bricks, refractory materials, lining of furnaces like magnesium oxide. Aluminum oxide, very strong. Al2O3 is its formula. Why it is so? Because aluminum belonging to group 3, atomic number 13. Atomic number 13 means it has 13 protons and 13 electrons. So 2, 8, 3 are the electrons divided into. 3 must be lost to keep things 2, 8. But in doing so, it turns into a 3 positive ion. It's an ion, not an atom. This is atom, oxygen. 2, 8, 2, 6. Atomic number is what? 8. So breakup is 2 and 6. It accepts 2 electrons. Turn to what? 2 minus. 2, 8 now. So look at the stability. The last shell is 8. It has 8. Both are isoelectronic like neon. Exact copy of neon configuration. 2, 8. Chill they are. But aluminum ion 3 plus, oxygen 2 minus. One aluminum atom gives 3 electrons, but oxygen accepts 2 electrons. So the formula unit states what? Look at the swapping, ignore charges, it turns to Al2, 2 comes here, right here, and 3 there. Al2O3 is the formula unit, one formula of ionic compound. And it also explains that 2 of the aluminum atoms pours how much electron in total? 6. And 2 of the oxygen atom, not 2, 3 of the oxygen atoms accept how much? 6. So it means 2 aluminum atom and 3 oxygen atom are locked in a relationship. Aluminum 6 electrons are accepted by 3 oxygen to turn into Al2O3, a chemical compound, an ionic compound, an ionic solid. Okay, so you can see this there in dot and cross diagram also. Aluminum, I'm showing only the valence electron now. Look at aluminum now, satisfied with 8 electrons, shown 8 electrons are there. 2 into Al, 3 plus. Why 2 into? Because there are 2 in the formula unit. And look at the 3 multiplied by 1 oxide ion. This is aluminum ion now and this is oxide ion now. Totally the nature is changed. Just like the sodium metal explosive 1 and chlorine poisonous. After that it's a table salt. So between the structure of atom and ion there is huge difference. Properties entirely changed. There is aluminum and 3 oxygen locked in dot and cross model. And again another example may be hydrogen, non-metal hydrogen it is, and mostly you will find hydrogen locked in covalent bonds, sharing the last shell and overlapping and making things comfortable by obeying duplet rule. Duplet rule means want to keep 2, but these are 2. Look at that, this is the example where metal hydride mean metal combining with hydrogen. Lithium, atomic number 3 has breakup 2 and 1. 1 makes it comfortable. It loses that 1 electron. So becomes Li1 plus. It means it has now 2 electrons. Like helium it is. Obeys the duplet rule. And hydrogen has only 1 electron. So it accepts that electron to turn into hydride ion. And after that it also becomes having the last shell 2 now completely. Complete transfer from lithium to hydrogen. Both turn like helium. Both got stable like helium. And lithium hydride. Here the lithium ion 1 plus, hydrogen 1 minus, locked in a relationship, square brackets you show, 1 plus, 1 minus, no mistakes there. There is the dot and cross representation showing basically how metals lose electrons and non-metals gain electrons. You can even multiply this with 2. So everything multiplies with 2 and multiply with this 3. Everything got multiplied with 3. Turning out to be a stable situation, the 2 of the aluminum ion pouring 6 electrons altogether and accepted by 3 oxygens. Same goes here. Any dot and cross, you need to know atomic number, see the breakup, find out the tendency to lose or accept for non-metals, and then how they are locked in a relationship in a formula unit, and then show it by dot and cross diagram. Ionic solids are formed by this way. We'll see the properties and structure. Done, Atif. Atif.